Thank you very much for joining today's online event about the software-defined substation and how to digitalize conventional substations. I'm here today with Edwin from Locamation, and my name is Jos from Willowtech. Before we start, have a short look at the agenda. You can ask questions at any time. So the presentation will take around 25 to 30 minutes. And during that presentation, you can ask questions in the Q&A section on top of the Zoom app. And at the end, we'll take around 15 minutes to answer all your questions. So please use the time and ask the questions at any time. Regarding the agenda, today we talk about the challenges for DSOs and TSOs, digitalization of conventional substations, also in regards to 61850. We are talking about merging units and especially the virtual merging unit from Locamation, how to run and use it on a Willowtech substation server. And then we go into use cases, how to digitalize by using a virtual merging unit and looking into the full path in the direction of the software-defined substation. Edwin, over to you. Can you tell us a little bit about Locamation?
Yes, of course, Jos, thank you. I hope I can be heard, that everything is okay.
Perfect.
Good. So, my name is Edwin Melenhorst. I'm working for Locamation in the Netherlands as a product owner for 61850 implementations. Locamation was founded in 1983 in Enschede in the Netherlands. And during the last 40 years, we have built a lot of experience in time-sensitive mission-critical process automation technology. Locamation has also proven to be the pioneer in centralized protection and control substation automation with its SAS sensor solution. And because of that, during this 40-year period, we have installed over 200 SAS sensor systems worldwide, including the Netherlands, Sweden, the United Kingdom, and China. So that's a little bit about Locamation. Over to you, Jos.
Thank you, Edwin. So if you cross the border from Netherlands to Germany, from Locamation office, you directly reach Willowtech. So we are located in Laar, next to the border of Netherlands in Germany. And Willowtech was founded in 1969, so we are 53 years young company, quite of innovative spirit and always working in industrial automation and transformation in regards also to digitalization. So we also work in substation automation, especially for transmission and distribution grids, and of course also for HVDC and FACTS transmission substations. Our digital platforms and solutions support power grids to software-define, computerize their grids and their systems, and also to master the problems of IT and OT convergence. Edwin, back to you.
Yes, thank you. The current situation in the transport and distribution of electrical energy puts the TSOs and DSOs for huge challenges. On the one hand, the traditional top-down energy production and transport and distribution has changed to an increasing influx of intermittent renewable energy, for example, from solar and wind parks. While on the other hand, the increasing popularity of electrical vehicles, the energy transition that is going on in the Netherlands, but also other countries, put a higher strain on the grid from both the generation side as well as the demand side. TSOs and DSOs therefore need to know in more detail the capacity of the grid. As 50% of the legacy substations do not support the digitalization needs of the TSO and DSO. Currently, this makes it difficult to use the electrical network in the most optimal way. We will not address the expansion of the electrical grid on the primary side here. This is also very much needed, but we want to address the extension or refurbishment of the secondary equipment in substations. Apart from the before mentioned uncertainty of the grid capacity, energy companies also struggle to upgrade and expand the secondary systems because of shortage of financial and technical human resources. And in many substations, secondary equipment does not reach their end of life yet, which means that premature renovating will destroy capital. So in short, the energy sector needs to digitalize the grid with smart solutions that can be installed and maintained with less personnel and should be future-proof. Locamation has developed innovative solutions in the past, and we are now on the brink of presenting yet another smart solution for substation automation. This is our virtual merging unit, which was based on the well-known 61850 standard. That will revolutionize the way process information will be presented to the substation automation systems. Next slide, please. The virtual merging unit is a solution that is built on a simple, robust sensors that are connected to a single software-defined merging unit, which is running on a commercially off-the-shelf industrial computer. In this case, for example, from Willowtech. The sensors do not need configuration in most cases, and the virtual merging unit can publish up to 30 sampled value streams for protection, measurements, metering, and other applications. Because the virtual merging unit is based on the 61850 standard, the way to multi-vendor solutions is still guaranteed. As you can see in this schematic setup, the voltage and current interface modules called VIM and CIM are connected to a commercially off-the-shelf network switch. The interface modules publish sampled value streams based on the IEC 61869 standard, which defines several variants for sampled value streams. The virtual merging unit itself is running on a substation server, again, commercially off-the-shelf industrial computer, and will provide the calibration and adjustment of the process data. The published sample value streams are then ready to be used by other third-party IEDs, or in the future, virtual applications running on the same substation server. You also see a BIM here, which is the breaker interface module. This interface module has several digital IOs for controlling breakers and monitoring breaker positions, for example. The next version of this product will also be based on 61850 communication, which will be goose messaging. The shown platform will provide electricity companies a migration path to software-defined substations. Initially, maybe by extending the functionality with a measurement application, and in the future, moving towards a complete centralized protection and control system. The extension can be done without having to install additional hardware, as the sensors and substation server are by then already in place. Okay, next slide, please. So, in short, we have a relatively simple, cost-effective and flexible way to implement IEC 61850 process bus and station bus in existing substations. In the future, the virtualization of substation functions offers extensible and upgradable functionality. It supports ultimate flexibility for bay replacements or extensions with third-party IEC 61850 IEDs. Various migration paths towards a full software-defined substation. It's up to the TSO or DSO in which way they want to build, refurbish, or extend their substations. There's complete flexibility. The sampled value streams are configurable for advanced measurement and monitoring, including mainstream APIs towards data analytics applications, for example, through a REST API. Engineering and testing can be done through the IEC 62850 system configuration language, also known as SCL. And we implement state-of-the-art cybersecurity by design, which is based on, amongst others, the ENCS security requirements. Okay, next slide, and over to you, Jos.
Thank you very much, Edwin. So when we have software-defined systems, we always need a server or computer where the software can run on. And in substations, we are facing extremely harsh environments, and those computers and servers need to meet the same requirements as traditional IEDs to run the same functions. That's why we developed the Willowtech substation server, and which is made for 650 substations. So it is fully IEC 61850-3 and IEEE 1613 compliant, which means temperature ranges from -40 to +75 degrees, very high EMC levels, very good against vibration and shocks. So it can operate under all conditions. At the same time, it is powered by a very strong CPU to run a lot of different software applications and complex algorithms. So in this case, we have an Intel Xeon CPU inside, which is powered by 4 cores, and we can operate with up to 8 threads. With a total memory of 64 gigabyte, we can run multiple applications in parallel on it. The server is able to fit in a 19-inch rack, so you can just plug it in traditional racks that we have there probably already installed. And it's totally passive, so there are no moving parts. There's no fan. Also the hard disk is a SSD, so also there's no moving part inside. The server is made for visualization and containerization of applications, so you can run more than one applications on it. So it can perfectly work in applications where you need to combine multiple software applications on one device. For the power supply, it meets standards to be powered by battery backed up systems, so 110 volt DC to 20 volt DC, or a traditional AC power supply can be used. If we're looking at the server in detail and all the interfaces, we see on the left side the two redundant and hot swappable power supplies, which could be AC DC or AC and DC. Or 2 DC. We can extend the system with different cards, up to 4. In this case, we have a HSR PRP card installed, so we can support hardware-based PRP or hardware-based HSR, which allows you uninterrupted operation and very high performance. If you need to visualize something, we have displays integrated, so 2 displays simultaneously. One over a display port, the other one over a DVI-D port. And then there are 4 gigabit LAN ports, and those gigabit LAN ports can also support PTP, so they are real-time capable and capable to work with real-time applications, so that you have also precision timestamping on it. Besides that, there are USB ports, COM ports for legacy equipment, and for timing there's additional USB input. In short, for the application that we are doing with Locamation, very important is that the substation server is supporting Linux real-time operating systems where the applications can run on, so that we can really work in real time. In addition to that, that the Gigabit Ethernet ports support PTP. And then for many other applications and substations, the HSR PRP support is very important, especially the hardware support, because software implementations often have issues in performance and might fail easier. Besides a real-time Linux operating system, the server can also work with Windows Server, so where you can, for example, run Hyper-V and different virtual machines, can run Windows 10. It can also run ESXi from VMware for virtualization, or for example, Ubuntu Linux or Debian Linux. If you're looking for real-time operating systems that are really hard real-time, it also supports the VxWorks one from Wind River, which you can also use on the server. If you have cloud applications and looking for cloud, the device is certified for AWS Cloud and also for the Azure Cloud. Okay, Edwin, over to you and explain us the use case.
Yes, if you can show me the first picture. So how can we digitalize an existing substation with the virtual merging unit? Here we have a substation with some conventional protection relays, which are connected in a traditional way to the primary process. And we have an RTU to provide access to the substation for supervisory control and data acquisition by a remote control room. This situation still exists in many substations nowadays. And by adding the next picture, please. By adding a part where Locamation's current and voltage interface modules and a substation server, we create a cost-effective and future-proof platform, which will immediately make accurate process information available and opens the possibility for station bus as well. So if we combine these two, next part, please. If we combine these two, the combination of the existing secondary equipment with the state-of-the-art VMU platform, this will provide immediately accurate process information to new IEC 6150 IEDs. And future extensions of the substation become much easier. Even extending the substation with additional base and IEC 61850 based IEDs will be less time consuming. The infrastructure is already present, working in parallel with the existing conventional relays. The big difference with the initial substation is that the network operators now have reliable and accurate process information, which will enable them to utilize the grid more effectively. Next slide, please. So we recognize that installing a process bus, network switches, new IEDs, new way of engineering, and all the other possibilities with IEC 61850 in many cases is just too big a step and currently maybe not necessary or even wanted. This is why we develop our products with a migration path in mind. Initially, a TSO or DSO can install some configureless sensors and the VMU with a measurement application, and they are ready to go. But in the future, they might want to extend the substation with new functionality because the substation server running the VMU is already in place. Adding new virtual functions will be possible without adding any new hardware. This is the true strength of the software-defined substation. And combining the VMU platform with third-party IEDs is also possible, as everything will be based on standardized IEC 61850 communications like sampled values, GUIs, and client-server communication. Okay, this can you show the second picture? Yeah, so here you see an example of some additional functions that can be run on the substation server. And these functions are all virtualized or software defined and run in containers or virtual machines on the substation server. So this way, the system can be extended based on adding new software defined functionality. Okay, Jos, this concludes my presentation.
Perfect. Then we now reach the Q&A section. So thank you very much for your presentation, Edwin. And let's have a look if we have some questions. And it looks like there are already few. I'll start with the first one. Is the virtual merging unit intended for testing and commissioning stages only?
No, sorry, that was Dutch. I mean, no. The virtual merging unit is intended to use in a process environment. So it will digitalize the primary process signals into standardized sampled value streams that can be used by metering and protection IEDs. So it's not only for testing and commissioning. But it's an interesting question too, because at the moment you transfer all this functionality into software and run it on one single computer, testing will be also much easier. So you can do a lot of testing before you commission your system. So in that way, software-defined substations will be more attractive, I think, for TSOs and DSOs.
Okay, thanks. So next one, what makes a virtual merging unit different from a regular merging unit?
Yes, so the term virtual here is pointing to that it is completely software defined and running on a commercially off-the-shelf computer. So there is no dedicated hardware to run this system on. And apart from that, the sensors are completely separated from the actual merging unit functionality. So we have very simple, small sensors that can be installed in the field near the process. And the information from these sensors is then processed by the virtual merging unit. And there the calibration of the signals can be done if wanted, and then produce sampled value streams. And like I said before, our virtual merging unit is capable of at least publish 30 sampled value streams in parallel. So that means you only need one virtual merging unit normally in a complete system.
Okay, so this also reduces the cost, right?
Yeah, if you look at that, of course, it's always a very difficult topic to talk about cost, because all the 61850 evangelists, so to say, will say, it's cheaper, it's easier. Of course, this is not always true. You have to look at this on a case by case. But we did some calculations about this, and in many cases we can reduce the cost in this particular part. If we talk about the hardware, with 25%, that's one thing. On the other hand, you will have less hardware, which means the mean time between failure lower. Mean time between failure will be higher. So your system will be more reliable. Right? You have a higher uptime specification.
Okay, great. Then the next one, do you support RAID configurations, hot swap, and hard drives? I think this is one for me.
Yes.
So yes, so the hard drives within the substation server are hot swappable. They can be configured in RAID 0 or RAID 1 or RAID 10. With the extension, we can also configure RAID 5 configurations. So there is a full flexibility of also supporting RAID configurations, swappable and field exchangeable of the hard drives. The next one, does a Willowtech substation server have use case of being used as a jump server for remote access applications? This would also be for me, I guess. Yes, so the Willowtech substation server can also be used as a jump host. You can run a standard operating system on it with different applications on it, and can also use it for firewall, you can use it for HMI, you can use it for gateway. Until now, most applications are really on the station bus. So where our customers are using it to run the HMI software from the large vendors typically, or the gateway software, or engineering workstation software, or with virtualization, combine all of those applications. Then the next one, does the Willowtech substation server support syslog and or SNMP for cyber and health of the server? Yes, so the substation server supports syslog and also SNMP. So you can read out those data from the server and monitor it on an upper layer system. Then, Edwin, one more for you. How many IDs can I replace with one substation server?
Yeah, this is a nice question. Yeah, this depends on the situation and the requirements of the TSO and DSO. In the future, it will be possible to implement a full software-defined substation on a single server. So this is really, really possible. I think it's also important to distinguish between IEDs and substation functions. A conventional IED can have many substation functions in it, and in a substation, in a software-defined substation, we better talk about substation functions because there are no physical IEDs anymore. Of course, there's always a limit on the number of substation functions that can run simultaneously on a single server. Think about the number of processors, processor cores, memory. But from our experience in the past with our SAS sensor solution, we were always able to run all substation functions on a single platform, on a single PC. And this was already possible more than 10 years ago. So nowadays, processors and memory capabilities have increased 10 or maybe 100-fold. So I hope that answers the question.
Yeah, in case it should not be enough cores and RAM, we could also stack Willowtech substation servers and combine multiple. So then you just share the load or keep it in a hot swappable or a hot standby environment. Then the next one, do you support redundant sampled SMV streams for MU2 protection IDs?
Sorry, I didn't.
So redundant streams from the merging unit to the protection IDs.
Redundant sampled value streams. Well, if you talk about redundancy, you want to be sure that if one system fails, the other one takes over, preferably seamlessly. So sending the same stream from the same virtual merging unit, from the same hardware, would not be very effective in that sense. So of course, you can always, if you talk about transport system operators, the redundancy becomes much more important. You could use two substation servers with two virtual merging units, of course. This makes it already more redundant. If you talk about HSR and PRP, this is not supported yet. We at least not from our interface modules, and they have a single connection to the merging unit. On the virtual merging unit itself, you could, of course, implement PRP and HSR.
Okay, thank you. Then an additional question: does the substation server support marine conditions? I think it's for me again. It should support them, but it's not tested or certified. For that, it's a very interesting question. We had that discussion internally just a week ago. So after this webinar, we come to you and check if this would be a requirement that we could fulfill and discuss that with you in detail. Then the next question, do the interface modules need configuration? I think it's for you, Edwin, again. Do the interface modules, do you need to configure them?
The configuration, yes. Well, this depends on the usage and the requirements of the TSO or DSO. The interface modules and the sensors will have several modes. One mode requires the VMU attached to it for calibrations and adjustments of the sampled process signals. In this case, the accuracy of the final information in the sampled value streams is higher and can also be used for power quality and metering. The configuration is then done in the VMU, in the software, the VMU software, which is also the publisher of the sampled value streams. Another mode does not require the VMU, so you only use the sensors. And in this case, the sample data is not calibrated. In this case, the interface modules can be used directly by the IEDs that can subscribe to multiple sampled value streams. If the TSO or DSO accepts the default configuration of the interface module, no configuration is needed. However, if, for example, the measuring transformer ratio, sampled value ID, destination MAC address needs to be configured, then a simple configuration tool will be available for this. But out of the box, with some fixed parameters, you could use a current interface module and the voltage interface module directly to a protection IED. So this is very powerful.
Great, thank you. Then the next one, can the sampled value have simulation enabled in the frames for testing purposes?
Right now, our virtual merging unit cannot be put in simulation mode. We are also looking very much into security issues here. So it's not possible to have a client-server connection. If we talk about IEC 61850 communication, it's not possible to have a client-server connection to the VMU. This is not implemented. It's also not necessary by the standard, so it only publishes the stream. What we are doing now for internal, but later also for more simulation, is that we digitize the interface modules as well. We make them virtual, so we can simulate primary process signals. And yeah, there you can play all kinds of scenarios on your virtual substation before you actually deploy it in the field. So in short, no, currently it's not possible to put the streams into simulation mode.
Okay, thanks. Then the next one, how many substations have you implemented with this technology?
With the latest technology, we are now running the several research tests with various partners, because the new interface modules are based on IEC 61850. But the technology that we use for our solutions is already available for many years, and we installed over 200 systems worldwide.
Okay, thanks. Then, interesting question: how are new cyber vulnerabilities identified and mitigated by Locamation and Willowtech? So maybe I start.
Okay.
So in this setup, for us, it's not that difficult because we are delivering the underlying server. So what we have to look at and work at is, of course, on BIOS level and on CPU and CPU core level. So there we are working together with the supplier of the BIOS, and then also with Intel and chipset manufacturers to, in case there is something, to close it and bring out fixes and solve it. Edwin, how are you dealing with that at Locamation?
Yeah, an important part, of course, of having virtual functionality is how do you deploy this? How can you update software from remote? So right now we do this with Ansible. We make it possible to install the operating system and the applications like the virtual merging unit through that software. In the future, when things are going to run on in containers or virtual machines, of course, this will be even much more easier because you can install the whole functionality as a whole in on the server.
Okay, great, thanks. So then we have another one. Can I run Windows software on the server? I take this first. So the Willowtech server can run Windows software. It can run Windows operating systems. So it works with Windows Server operating system. It runs with Windows 10 operating system, and there you can run all types of Windows Server on it. The Locamation applications are Linux applications, correct, Edwin? So if you want to use it with Locamation, you need to use it with Linux.
Yes. Yeah. So we have decided to develop our solutions on Linux real time as an operating system, and for the VMU and future substation functions like protection and measurements. Our software is designed to work on Linux for the highest reliability and flexibility. So the VMU cannot be run on Windows, but Willowtech servers, of course, can run different operating systems for different needs.
Okay, great, thanks. Then another question: are the Vim, Sim, and BIM also Welotec products? No, it's not. Those products are from Locamation, Edwin, right?
Yes. So we already have a lot of experience with these modules. In the past, these modules were producing proprietary streams. There was a proprietary sampled value stream, so to say, from these modules. But now we have converted this into IEC 61850 sampled value streams. So no, the interface modules are developments of Locamation.
Okay, thanks. Then there's a question about network redundancy, PRP, HSR, SDN, so software defined networking, and if the hardware is prepared for it. Let me take that from the Willowtech substation server. So the Willowtech substation server supports hardware-based PRP, hardware-based HSR, and of course software-defined networking, because it's a computing platform, can run on it. We, for example, have a cooperation with Fortinet where we can run a Fortinet firewall on it, and there you can have all those software-defined networking functionalities through the software of Fortinet. Then next question would be, from point of view of IT infrastructure, this machine is similar to industrial server, a lot of RAM, RAID, double processor. Yes, so it's industrial server. It has a single processor. It has up to 64 GB of RAM. Supports RAID configuration, and it can also work with VMware ESXi for visualization, and is used by many utilities also with ESXi. So you can use it, and well, it is an industrial server. The only difference to a standard industrial server is that it is totally fanless, that it can work in very harsh environments, and that it meets the IEC 61850-3 and IEEE 1613 standards. Then the next question, is there any use case to remove RTU by means of substation server?
Yeah, I can give a little bit answer on this, I think. Well, remote terminal unit, I think in most cases is used for connecting to a substation. I think nowadays we talk more about gateways in substations. So you have a gateway to which is like a proxy for the outside world, and on the inside the gateway is a client to all kind of process information or station bus information. So basically, yes, this can be all run on the same substation server. I think you have to see the substation server with all the virtualized functions that internal. All these functions are still connected by a process bus and station bus, although being it not a physical bus, but all these functions can run together on one computer. So I think it would be possible to remove the RTU. Yes.
Yeah. Maybe also from Willowtech. So we have a lot of mainly transmission grid customers who are using our Willowtech substation server and run usually gateway or RTU software from the large vendors on it. So it can work without an issue and is installed in many installations globally. Then the next one. What are the capabilities of the visual protection software module?
I think this is also, again, for me, I have to be clear that currently we don't have a virtual protection software module. Maybe one other misunderstanding is that Locamation will create all these functions in the future. This platform will probably be created by LFE, Linux Foundation for Energy, with their CPath project. So this will be a platform, but we are also contributing to that, where in the future different parties can create their modules. So they can create specialized protection functions, for example. And yeah, what are the capabilities? The capabilities will be the same. The only thing is it's now virtual. So on the front side, a protection function will subscribe to sampled value streams that are needed for its protection function. And on the back end, if you want to open a breaker, this will be done by sending a goose message to a breaker interface module. So that is a little bit how you have to see the concept of these software-defined substations. So capabilities will be the same with conventional protection IEDs.
Okay, great. We have another question regarding protection modules, and this is what is the overall response time of a virtual protection module detection to trip time?
Let me see. Yeah. This is a little bit out of my comfort zone, so to say. I don't know the exact times for this, but maybe I can send this person the answer after I consult some colleagues. I don't know the exact time, but it should be at least as fast as with conventional IEDs, of course.
Yeah, I remember your colleagues showing it to me in your office that it meets the same requirements as conventional ones.
Yeah, but I'm not going to name any numbers if I have no idea how much it is. So,
yeah.
But I can send an answer to this person.
Perfect, thanks. Then another question, do you have direct SCADA link from the substation server to SCADA systems via IEC 104? Should I do that?
Yes, maybe.
Okay, great. Well, yeah, talking about what Edwin said before, if you want to have 104 connection, you would need another gateway module or RT module that can also run as one container on the substation server. There are software vendors that offer these functionalities as containerized functionalities, and they can be used in combination with the virtual merging units and other solutions. Okay, then let me check.
I have a lot of questions today, so
yes,
which is good.
How does a VMU handle multi-protocol between equipment in the substation?
Let's see, where is the question?
Virtual merging unit, multi-protocol between equipment in the substation.
I don't see the question. Can you ask again? Tell me again.
How does a VMU handle multi-protocol between equipment in the substation?
Multi-protocol. I don't know what is meant with that.
Okay, please get in contact with us after the webinar, and then we will clarify that question.
Yeah, the only thing I can say here is the virtual merging unit publishes sampled value streams, and there will be various variants as defined in IEC 61869-9. There will be some variants that we support. One of them is the backwards compatible 9.2 LE, and one will be a preferred new variant, which will be the 4800 hertz sample rate. Yeah, so we will support at least two new sampled value streams.
Okay, great, thanks. Then the next one, does a Willowtech substation server come with guidance on hardening of the physical and virtual instances? Of course, so we can discuss with you based on your applications and what you need, how to harden it and how to protect it, and also if needed, if we put some kind of additional firewall or additional IT and OT security mechanisms on board. Then another question again regarding latency. What are the latency time of the VMU in metering and control? I think we need to answer that afterwards, right?
Yes. Like I said, I don't have any numbers in my head right now, so that's difficult to answer. But I want to say, maybe if people want have specific questions, please don't hesitate to send me an email. I think the email address is on the screen. I'm more than willing to answer your questions. So I hope people do that.
Great.
And the same for people. I see a question: how expensive is this product? I don't know which product you mean, but I think here too, I think it's better to contact us directly.
Yeah, for quotes and project discussions, so we are both open to discuss at any time. Yeah. But now another question: software defined substation is fully cyber secure as well. Well, let me take that first. So if you're talking about software defined substations, you have the same issues with any other software and IT system to protect it from cybersecurity threats. The good thing about software-defined and IT systems is that usually latest defense technology are available. If you're talking about legacy equipment and IEDs, it's more difficult to upgrade and update them without manipulating the functionality and without additional testing. So what we see in the field and what we do quite a lot is that we are running firewalls on the substation server with some kind of functionality where we can filter the traffic that is going from and to the IDs to check for vulnerabilities because they're not patched or not patched in time or patches are not available anymore. So with software-defined systems, it becomes easier to upgrade. Software maintenance will be faster. It's easier to secure by firewall and IDS systems. So cybersecurity will be higher than for typical distributed OT systems. Edwin, you want to add something?
I just had a cough, so my voice is maybe a little bit disturbed. No, the only thing I can say is that we try to follow all the cybersecurity standards and recommendations, especially from the ENCS. And yeah, so we try to be as secure as possible, of course. But the question, fully cyber secure, I think there will not be any party in any domain that can claim that everything is fully secure. It is never secure, 100%. The thing is, what do you do when, for example, a hacker enters your substation? If this would be possible, if you want to make it fully secure, then yeah, you don't have any contacts to the outside world, and you should probably not use communication networks and things like that. So, but this is not an option anymore, of course. So yeah, we follow the standards and the requirements from ENCS.
Okay, thanks. Then another question: can the server be the boundary clock? I think I take that. So the server itself cannot be a boundary clock. Usually we are using switches or other devices as this boundary clock. But with integrated HSR PRP card, we are also fully PTP capable. And then we can be a boundary clock, but the underlying software might have additional delays in it. So we need to look into your detailed application to check if it can meet your requirements. Okay.
Yeah, I think also in this question, it's more common that a switch is a boundary clock, and yeah, it's more common that network components are boundary clocks.
Okay, so it looks like we answered all your questions. Thank you very much for joining. If there are additional questions, please let us know and get in contact with us by email, or you can also get in contact over phone or Teams or LinkedIn, whatever it is. We are more than happy to answer all your questions and well, hopefully also work together with you. Thank you very much and have a nice day, and see you soon for the next webinar.
Yes, I want to thank also all listeners for participating. Thank you very much.
Bye-bye.